So we are saying we have the two forces 120 um, apart, 120 degrees apart. The bigger force is 40 newtons. The resultant makes 90 degrees with the smaller one. Find the smaller force. We have drawn our parallelogram, and the bigger force will occupy the bigger size at the bigger side of the parallelogram, and obviously the smaller force will occupy the shorter side of the parallelogram. And the resultant makes an angle of 90 degrees with the smaller one. We have indicated that the two are at 120 degrees, the short one and the bigger one. Then if this is 90 degrees and this is a straight line, then this becomes 30 degrees. So we needed to prolong this so that we add up angles on a straight line, which should be 180. So if this is 120, this should be 60 degrees. So if it is 60 degrees, we need to get the component of this force F1, the component of this force vertically, and the component horizontally. The vertical one has a sine, so the angle here is 60. The horizontal one is F1 cos 60 also. So basically, what we put here is the same as what we would put here, because the parallelogram is like this. Let me draw it the way it is here. Our parallelogram, our parallelogram is like this. So this angle here, if this is a straight line, this one would also form a straight line here. So this angle here, if this is 60 degrees, obviously it would also inform us that this is also 60 degrees. Because what is here is 120. If it is 120, then this becomes maybe 60. Okay, if this is 60, also this becomes 60 degrees. And what is here will also become 120 degrees. So I'm just trying to tell you what would be from here. For example, if we draw a vertical one touching this point from here to here, it's the same as from here to here. So if this is our shorter force F1, then if this is we would take a component equivalent to maybe F1 cos, this one will also take a component F1 equal to, F1 cos 60 degrees. So that's why I'm borrowing it and trying to use to create it here and then use it here. So this is F1 cos 60 degrees. So we proceed. So we use our formula, tan alpha will always equal to the force which is up here, F1 sine of the angle it makes with now this other one. So if it was to make 120 degrees, then it would be the components would actually vary. But since we can see, if I prolong, you remember the principle of transmissibility of a force. We said that if the point of action, if the line of action of the force is somewhere here, we can always extend it along that line of action can always be extended. So you'll find we can extend the line of action of F2 and still find that the angle F1 makes with F2, okay, is also 60 degrees. If we are talking about an angle between 90 and 0. The angle above 90 would be the 120 degrees. But this one looks to be easier to deal with, to generate easily the sine and cos components. So F1 sine 60, 40 minus F1 cos 60, because we said we are interested in the distance from here to the end of the resultant. The resultant ends somewhere here. Okay? So that's why we are interested in knowing what is this, because we already know from here to there, so that to get this distance, we just get this minus that, and that would be enough for us to proceed. So it's equal to tan 30 degrees, because we have already seen that if the resultant makes an angle of 30 degrees with the horizontal. So we proceed and substitute in. Remember, this is a 60, this is 60. Then, of course, we need to manipulate our results using a calculator. We should be able to get these answers. So you can correct the right terms where there is F1, you put them together. I take this to the other side, so that I have F1 into sine 60 plus cos 60 times tan 30 degrees. And this is equal to 40 tan 30 degrees. What is that? So this will be sine 60 plus cos of 60 times tan of 30. We are saying cos 60 times tan of 30. So we see that we have 1.5, 1.1547 F1 equals 40 tan 30. So our F1 obviously will be 40 tan 30 divided by 1.1547. So 40 tan of 30 divided by that answer. Our answer becomes 20 newtons. And this one can at least make sense, because our value is supposed to be a smaller value, smaller than 40 newtons. So the smaller force should give you 20 newtons. So we can check our final answer, and you can see it is 20 degrees. So members, that's how we can apply the parallelogram law of forces in getting the resultant force of two forces that would form sides of a parallelogram.